the video again because everything crashed and then I didn't get a pause, so I'm going to have to cut that video and start again. So here's a defective versus a good. Now this is my first choice of a radio. I have to do this 4 times. So on the second choice I could get a defective or a good, or I could get a defective or a good based upon what I got the first time. Now the third time I could get a defective or a good, I could get a defective or a good, I could get a defective or a good, I could get a defective or I could get a good. Now one last time over here, I could get a defective, a good, 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 and a defective, and a good. Now this would give us all of our possibilities. So if we write those out, that would be a defective, 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 defective. In other words, they're all defective. Or a defective, and then a defective good. And then a defective, defective, good, defective. And then a defective, defective, good, good. And then a defective, good, defective, defective. And then a defective, good, defective, good. And then a defective, good, good, defective. And then a defective, good, good, good. And then a good, defective, defective, defective. And then a good, defective, good, defective. And then a good, defective, good, good. And then a good, and then a defective, and then a good, good. No, wait a minute. Good, defective, good, defective. Oops, that one should be good, defective. Did I do this? Okay. 1, 2, 3. 1, 2, 1. This should be the third one. Defective, good, defective, 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 good, defective, good. Oh no, I'm over here. I lost track. I'm sorry. Good, defective, defective, defective. Good, defective, good, defective, good, defective, defective. Let me just erase all these and start over again. Okay. Good, defective, defective, and then good. Good, defective, defective, and then good. And then good, defective, good, defective. Good, defective, good, defective. And then good, defective, good, good. Okay. Now over here on the very last one. Good, good, defective, defective, good, good, defective, good, 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 defective, and then good, 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 good. And that was good, good, defective, defective, good, 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 defective, good, 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 defective, good, 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 good. Okay, now we notice that there are 2 choices here, 2 choices here, 2 choices here, and 2 choices here. So we should have a total number of outcomes, 2 times 2 times 2 times 2, which would be 16 possible outcomes. There's 4 in each of these, 4 times, let's see, 16, 4 times 4 is, okay, so we should have a total of 1, 2, 3, 4, and 4 rows. 4 times 4 is 16, so I should have total of 16 possible outcomes as I expect. So now, once I have written this, now my job is to do a probability distribution function. So probability distribution function, since I'm kind of out of room here, I'm going to do a horizontal one. Remember that horizontal is perfectly acceptable. So I'm going to put my x's up here and my probability of x's down here. So my random variable is going to be defined as the number of defective radios. So x is going to be equal to number of defectives. Okay, so that's really important. Remember to define what your random variable represents so that everybody stays very clear about that. So obviously in a batch of 4 I could have 0 defectives, I could have 1 defective, 2 defectives, 3 defectives, or I could, have 4 defectives. I do not know where that 8 came from. That's crazy. Or I could have 4 defectives. All right, so now if I have 0 defectives, that means they're all good. There's 1 out of my 16 chances that that could happen. Having 1 defective. So this one right here has 1 defective. That one right there has 1 defective. No, that one doesn't. That one right there has 1 defective. No, no, no. That one right there has 1 defective. No, 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 no. So I have 1, 2, 3, and 4 that are boxed. So there's 4 out of 16 that have 1 defective. Now looking for 2, I'm going to change to a highlighter this time. So let's see, 2 defectives. So there's 2 defectives. That one has 3, that one has 2, that one has 2, that one has 3, that one has 2, that one has 2, that one has 2. So there we go. So our total here, 1, 2, 3, 4, 5, and 6. So I have 6 out of 16 that have 2 defectives. Now let me change to just circling them. So this one I'm going to cross off since how it was my first one for 0. And so now circling those that have 3 defectives. So this one has 3 defectives, that one has 3 defectives, that one has 3 defectives, and that one has 3 defectives as well. So now I have 4 that have 3 defectives. And then very last one, I'm down to that all of them are defective, and there's only 1 left that's an all defective. Now if we add all these up, 1 and 4 is 5, 11, and 15, and 1 more makes 16. So we see that that's perfect. Now what you just saw me do here is this is crazy. That's really hard to be able to find probabilities this way. So what we need to be able to do to find these probabilities more easily is say how many outcomes they are. So counting total number of outcomes, you know how to do that with the basic counting rule. 2 times 2 times 2 times 2, which is equal to 16. And then the way that we count among 4 things that we could choose 1 that was defective, or 2 that was defective, or 3 that were defective, or 4 that were defective. Any one of these things, this is a combination. It's a C of 4. Choose how many ever X we're talking about. So let's just show that with the 3 here. So the combination formula for 4 choose 3, remember, this is 4 factorial, the n factorial, the total number of them, divided by 3 factorial, that's my x, and then 4 minus 3, and that being factorial. So this gives me 4 in the numerator times 3 times 2 times 1, that's in my numerator, and then 3 factorial is 3 times 2 times 1, and then 4 minus 3 is 1, and 1 factorial is just 1, so that's another 1. So all of these cancel with all of those, just some basic math, which just leaves 4 over 1, and that's equal to 4. And that is how I can count the number in the numerator. So this is my numerator. Let's see. Choosing 3, right? So this one here, the numerator is 4, and then out of the total number of outcomes, which we counted with the general counting principle, and that's 16. And that's how you can find those probabilities. So this leads us right into the binomial distribution function. And